My dear students, in the previous video, we have completed the exercise 3.4 in the chapter trigonometric functions. Now, in this chapter, 6 linear inequalities, the 6th chapter, linear inequalities, is a new chapter we are going to start in this video. Linear inequalities is a new topic. What is meant by linear first of all? The linear inequalities, linear means any algebraic equation of degree, unit degree. See, x plus y equal to 5. This is called a linear equation. X power 1 plus y power 1 equal to 5. That means the variables have unit degree are called linear equations. If the variables have second degree, x square plus y square equal to 5 like that, it's a quadratic equation. So, linear equation means the variables having only unit degree. The degree of the variables are 1. So that they are called linear equation. If this equation can be replaced by an inequality, then it is called a linear inequality. So, linear inequality means equality can be replaced by some inequality symbols. What are the inequality symbols? See, this symbol is greater than, this is less than, this is greater than or equal to. If you put an equal here, it is greater than or equal to, this is less than or equal to. These are the 4 inequality symbols we are going to use in this chapter, linear inequalities. The topic, study of linear inequality is very much used in the solving problems in the subjects science, mathematics, statistics, economics and psychological problems. See, these psychology problems, in this topic, the linear inequalities are used to solve the problems in the various subjects I have told already, that is science and technology, mathematics, engineering, and statistics and so on. So from those subjects, these inequalities are used for solving the problems. Now, to solve the inequalities, we have to follow some 2 rules. Rule 1 states that in an inequality, a same number is to be added on both sides or subtracted on both sides. If in an inequality, a same number should be added or subtracted, the inequality is not changed. That is rule 1. In an inequality, if a same number, suppose y less than minus 2, if you add 5 on both sides, the inequality is not changed. Similarly, you subtract a number from this y, like that. If you add or subtract the same number on both sides, the inequality is not changed. That is first rule. The second rule, if you multiply by the same number on both sides of an inequality, or if you divide an inequality by the same number on both sides, the inequality is not changed. If you multiply an inequality by the same number or divide the inequality by the same number, the inequality is not changed. Whereas if you multiply or divide by an inequality as by a negative number, if you multiply by a negative number, the inequality is reversed. This greater than or equal to should be less than or equal to, like reversed as less than or equal to, because I multiply minus 2 on both sides. Less x greater than or equal to 7. If I multiply minus 2 on both sides, it becomes minus 2x less than or equal to minus 27. Similarly, if you divide by a negative number on both sides of an inequality, the inequality is reverse its order. The inequality is reversed. See, if I divide by x by minus 3, greater than or equal to becomes less than or equal to 7 by minus 3. So, rule 1, if you add or subtract any number with an inequality, the inequality is not changed. Similarly, if you multiply or divide by a positive number on both sides of an inequality, the inequality is not changed. The only case is if you multiply or divide the inequality by a negative number, the inequality is reversed. You remember these rules. On the basis of these rules, we are going to solve the problems in the exercise First exercise step 6.1. We will see the problems in the exercise 6.1. Normally students get confused with this inequalities. Don't get confused. This is greater than symbol, this is less than symbol, this is greater than equal to symbol, this is less than equal to symbol. The only you have to remember that 10 greater than 7. So the broader open side is always on the bigger number. The sharpened side is towards the smaller number. It is greater than. Greater than means the sharpened edge is towards the smaller one. Whereas 7 less than 10. In this case also, the sharper one is towards the smaller one. Therefore, this is less than. 10 is greater number. The open side is towards the bigger number. See, you remember the sharpened side of number should always be smaller, whether it is greater or less. 10 greater than 7. In terms 7 less than 10. These are the ideas you have to keep it in your mind while solving the problem. Because the student get confused which is greater than symbol and which is less than symbol and so on. And normally the student get confused. So you please be remember these are the 4 identities, inequalities we are going to use in the exercise. Exercise 6.1. First problem. Solve the inequality 24x is less than 100. 24x is less than 100 when x equal to, when x is belongs to a natural number. First case when x is belongs to a natural number. Second, x belongs to the set of integers. X belongs to the set of natural numbers and x belongs to the set of integers. Natural numbers means the set consisting of number 1, 2, 3, etc. up to infinity. This set of natural numbers. The set of integers is negative, all negative integers. And all positive integers including 0 is called set of integers, Integers consisting of all the positive integers and negative integers including 0. Whereas the set of natural numbers is only 1 to infinity. Or only positive numbers excluding 0. This is set of natural numbers. Now, one more thing. The set of real numbers, real numbers is also minus infinity to plus infinity, including all real numbers, whole numbers, positive numbers, negative numbers, fractions and everything also. All real numbers are including the set of real numbers. Here, these are consisting of only whole numbers. Whole numbers only you are considering. But in this case, whole numbers, positive, negative and fractions also included in the set of real numbers. Now, for come to this problem. First case, given problem is 24x is less than 100. First, when x belongs to the set of natural numbers, we will give for x equal to 1. If you put x equal to 1, because the natural number set starting with 1, 24 is less than 100 is true. If you put x equal to 2, 2 into 24, 48 is also less than 100 is also true. If you put x equal to 3, 3 24s are 72, which is less than 100, which is also true. If you put x equal to 4, 4 into 24, 96, which is also less than 100. If you put x equal to 5, 5 24s are 120, which is not less than 100. Here, the inequality fails. If you put x equal to 5, the inequality fails because 120 is not less than 100. Therefore, the solution set for x belongs to n. For x belongs to n, the solution set is 1, 2, 3, 4 only. out of these natural numbers, up to 4 only you can consider for this inequality, because up to 4 the inequality true. If you put x equal to 5, the inequality fails. Therefore, this is the solution. Come to the second stage. This is for second case. For x belongs to a set of integers. See, if you put x equal to 1, you will get 24, 2, 3, 4. You get up to, you satisfy all the 1, 2, 3, 4 numbers satisfies the inequality. 5 should not satisfy. Therefore, the set of integers after 5 are not satisfying the inequality. But whereas come to the left hand side, when x equal to 0, 0 less than 100. When x equal to minus 1, minus 24 less than 100. When x equal to minus 2, minus 48 less than 100. When x equal to minus 3, minus 72, which is also less than 100, minus 72. All the negative numbers, if you substitute for x, you will get negative numbers only. All the negative numbers are less than 100. Therefore, the solution set is, the solution set for the set of integers is all the negative numbers 1, 2, 3 up to 4. Up to 4 already for natural numbers we have proved. After that, the x is 0, minus 1, minus 2, etc. All the negative numbers are also satisfying this inequality, because all the negative numbers, if you substitute for x, they are certainly less than 100. Therefore, the solution that is minus infinity to 4 is the solution for x belongs to z. That's all about the problem 1. You remember, considering the nature of the set, the solution is existed. If the set is set of natural numbers, the solution is up to 4. If the set of integers, 4 elements, apart from that, all the negative numbers. Our solution for x belongs to z. That's all. Next, second problem. Second problem, also solve minus 12x is greater than 30. Minus 12x is greater than 30. In this case also, x belongs to a set of natural numbers, and the second one is x belongs to a set of integers. See, n consisting of all positive numbers only. Consider minus 12x is greater than 30. This is the inequality. If you could, if I consider if x belongs to a set of n natural numbers, we will substitute x equal to 1 minus 12, which is less than 30. If you put x equal to 2 minus 24, less than 30. If you put x equal to 3 minus 36, which is also less than 3. 36. If you put x equal to 4 minus 14. See, all the positive numbers, if you substitute for x, it leaves only the negative number, because it is minus 12 into x. Since the inequality containing difference set is minus, all the positive numbers belonging to the set n gives only the negative numbers. They are all certainly less than 30. The inequality is not satisfied. Therefore, for x equal to n, x belongs to n, there is no solution. There is no solution for the inequality, because all the natural numbers, if you substitute for x, they leaves you only negative number. Negative numbers are all less than 30. Therefore, the inequality fails for all the n belongs to the set of integers, set of natural numbers. Therefore, there is no solution. Whereas in the case of set of integers, second case, if x belongs to z, up to 1 positive numbers are not satisfying the inequality. Consider 0. 0 is also less than 30. 0 is not satisfying the inequality. If you take x equal to minus 1, minus 1 into minus 12 plus 12, minus 1 into minus 12 plus 12, which is also less than 30, not satisfied. If you put x equal to minus 2, minus into minus plus 24, which is also less than 30, is not satisfied. If you put x equal to 1, x equal to 0, not satisfied. If you put x equal to minus 3, if you put x equal to minus 3, you will get minus 12 into minus 3, that is equal to what? Minus into minus plus 36, which is greater than 30. It satisfies the inequality. The solutions are start from minus 3 only. Therefore, all the negative numbers from minus and for x belongs to z. The solution set is, the solution is minus infinity to minus 4, minus 3 only. Because minus 2, minus 1, 0 and every positive numbers are not satisfying the inequality. Therefore, this is the solution set for x belongs to z. This is problem 2. Okay? And one more problem. Problem 3, we will see. Problem 3, solve 5x minus 3. 5x minus 3 is less than 7. 5x minus 3 is less than 7. In this case, if x belongs to z solution and if x belongs to real numbers, you consider the solution for these two sets. For first case, for x belongs to a set of integers, 5x minus 3 less than 7, you bring this minus 3 to right hand side, it is 5x is 7 plus 3. Minus 3, if you bring it to right hand side, it becomes plus 3, it is less than 10. 5x is less than 10, so x is less than 10 by 5, that is 2. So x less than 2, for set of integers, x less than 2, up to 2 only the x values. See, this is set of integers, minus infinity, minus 1, 0, 1, 2. So x less than 2 means the numbers along this direction. This is called x less than 2. X less than 2. Therefore, for x belongs to z, the solution is minus infinity, etc., minus 2, minus 1, 0, 1 only. Because if you put x equal to 2, 2 less than 2 is not true. 2 less than 2 is not true. Therefore, up to 1. X less 1 is less than 2. So, up to 1 for set of integers, this is the solution set. For up to 1, minus infinity to 1 is the solution set. Whereas in the case of set of real numbers, if x is a set of real numbers, the solution set is, see, up to 1 only, 1 less than 2. Okay, but in between 1 and 2, there are some real numbers. This is 1.5, 1.25, 1.75, 1.99 and something. So, if in the case of real numbers, you delete except 2. All the real numbers is all the solution. See, up to this, except 2. This is the solution set. The except 2. Like that. You eliminate 2 only. That is, the solution set is up to 2. So, the solution set is minus infinity to 2 open interval. Open interval means 2 does not included in the interval, but next to 2, 1.99 up to 1.999 is the solution because it is also a real number. Therefore, if x is belongs to set of R, the solution set is minus infinity to 2 open. Because that means the endpoint 2 is not considered, but up to 2. Next to 2, I mean 1.99 up to that number only we will consider. Therefore, this is the solution set for the problem if it is a case of real number. Suppose if you put 2 as closed, if the 2 included, That's why I write it as an open interval. 2 does not include. That's all about the problem 3. Thereby I stop the video here, and we will continue the remaining exercise problems in the next video. Thank you.